For literally thousands of years, there's been one thing in the sky that has consistently freaked people out and also left them totally in awe. Yep, I'm talking about the blood moon.
Okay, so picture this. You step outside one night, you look up, and the moon, our familiar silvery moon, it's just gone. And in its place is this dim, kind of eerie orb, glowing this deep coppery red. It's unsettling, right?
And for most of history, you can totally see why this was a terrifying sight. I mean, with no science to explain it, cultures all over the world looked up at that and thought, uh-oh. They saw it as a divine warning, a celestial sign that something awful was coming, like war, catastrophe, or, yeah, even the end of the world.
But here's the cool part. The reality of the blood moon. It's not some ancient prophecy. It's actually a breathtaking demonstration of physics playing out on a cosmic scale. And once you get it, it gives you a whole new way of looking at our own planet.
So, what's really going on up there? Well, it all kicks off with this perfect straight-line cosmic dance in space.
That thing we call a blood moon, it can only happen during one specific event, a total lunar eclipse. That right there is the first, most important piece of the puzzle. Okay, so a total lunar eclipse happens when the sun, the earth, and the moon get into this perfect lineup, exactly in that order. Earth gets right in the middle, completely blocking the sun's direct light from hitting the moon. It casts this deep, dark shadow. It's called the umbra, and that shadow falls right across the moon's face.
Which, leads to a pretty obvious question, right? If the moon is completely stuck in Earth's shadow, why does it glow red? I mean, shouldn't it just disappear? Go totally black?
Well, the answer, the secret ingredient that makes a blood moon, it isn't out there in deep space. Nope, it's right here, in that thin, fragile blanket of air that surrounds our own planet. See, even when the Earth itself is blocking the sun, our atmosphere actually pokes out a bit past the solid edge of the planet. So as sunlight zips by, it grazes the edge of our world and has to punch through that layer of air before it can continue on its journey towards the moon.
And this is where a really cool piece of physics kicks in. It's called Rayleigh scattering. Don't worry, it's not as complicated as it sounds. It's just the rule that explains why different colors of light act differently when they hit tiny particles. Like, say, the molecules in our air.
And what's so cool is that Rayleigh scattering explains stuff you see every single day. So, sunlight looks white, but it's really made of all the colors of the rainbow. Blue light has these short, frantic little waves. They bump into air molecules and scatter all over the place. Boom. That's why our sky looks blue. But red light, it's got these long, chill waves that just cruise right on through the atmosphere without getting bounced around as much. This is exactly why sunrises and sunsets are red. The sun is low, so its light has to travel through way more atmosphere, scattering away all the blues and leaving just those amazing reds and oranges for us to see.
So let's connect the dots. During a lunar eclipse, our atmosphere acts like a giant, planet-sized color filter. It takes the sunlight, scatters away all that blue light, and lets pretty much only the red light sneak through and continue on into Earth's shadow.
But wait, it gets even cooler. Turns out, not all blood moons are created equal. Sometimes they're bright red, sometimes they're a dull copper, sometimes they're barely visible. And why they're different? Well, that tells us something really fascinating about what's happening right here on Earth. Let's look at a specific case. Back in 1963, astronomers were watching a lunar eclipse, and they noticed something weird. It was super dark. It didn't have that classic reddish color they were all expecting. So, what was going on?
Well, here's the crazy connection. Just 9 months before that eclipse, a volcano, Mount Agung in Bali, had a massive eruption. It shot tons and tons of dust and ash high up into the stratosphere. All that extra gunk floating around in our atmosphere acted like a thick curtain, blocking even more sunlight from getting through. And that's what made the 1963 eclipse so dark.
So here's the main takeaway. The color of a blood moon is basically a report card on Earth's atmosphere at that very moment. If our air is clean and clear, you get a bright, coppery red moon. But if the atmosphere is full of stuff like volcanic ash, thick clouds, or smoke from huge wildfires, you're going to get a much darker, dimmer eclipse. Sometimes it can even look almost black.
Okay, let's put all these pieces together for one last really mind-blowing image.
All right, so we know that only the red light gets through our atmospheric filter. But here's the thing. Our atmosphere doesn't just filter the light, it also acts like a giant lens. It actually bends that light or refracts it inward. And it focuses all of that bent red light right into the cone of shadow behind Earth, basically painting the moon's surface with this faint reddish glow.
And this leads to what is, hands down, my favorite way to picture this whole thing. Imagine you're an astronaut standing on the moon during one of these eclipses. You look up and see the Earth as a big black circle blocking out the sun. But all around the edge of that black circle, you'd see a brilliant, fiery red ring. And what is that ring? It's the light from every single sunrise and every single sunset happening on Earth, all at the exact same time. The blood moon is literally being lit up by the glow of all of Earth's dawns and dusks combined. How amazing is that? Now, when you think about that, you can totally understand why our ancestors, who had no idea about atmospheric physics or light scattering, looked up and saw that blood-red moon as a powerful and, often terrifying message from the gods.
But today, we know better. The blood moon isn't a prophecy of doom. It's a projection of our own world onto another one. It's this incredible silent light show, all thanks to the perfect geometric alignment of the sun, the earth, and the moon.
So, the next time you get a chance to see a red moon hanging in the night sky, what are you going to see? An ancient omen of the end? Or will you see the combined light of every sunset on Earth, filtered through our own atmosphere and painted across the face of another world? The universe just showing off its elegant, beautiful mathematics.